Okay, let me introduce you to angle of elevation and depression and just show you quickly how this looks. If I have, like, let's say the ground here, and it's always going to be horizontal ground and some, usually a building or something there in the distance, the angle of elevation, let's say from this point, will be the angle to the top of the building. And so we can call this any angle here. Maybe this is 30 degrees, and that will be my angle of elevation. Okay, notice, by the way, that let's say I was at this point here, my angle of elevation to the top of the building will be larger. You can see that this becomes larger than this angle. In other words, if this is 30, maybe this would be 50 degrees, for example. Okay, so the difference between these. And as I went further back, maybe at this point, my angle of elevation becomes smaller. Maybe this is 20 degrees. And so just some examples here. As I walk towards the building, I have to look higher and higher and higher into the sky to get to the top of the building. So my angle will increase. This is called angle of elevation. Again, it's from the horizontal up. There's also something called angle of depression. And if I draw the exact same picture, imagine we're looking from the top of the building down. So maybe I'm looking to a point here on the ground right here. And so as I look down here to this point, okay, my angle of depression will be from the horizontal line. Okay, it's always from the horizontal, not from the building, but from the horizontal. Going down here will be my angle of depression. So maybe this is now 25 degrees. And so that's my angle of depression. Notice, first of all, that if I went further out to this one, my angle of depression, okay, it's harder to see here, but it'll be smaller. It won't be 25 anymore. Maybe now it's 15 degrees. Okay, so it'll get smaller and smaller and smaller as I get further and further out, just like this one did. Something I want you to notice, though, with angle of depression and an elevation is that, in fact, if I draw that same picture again, okay, and I have a point here, and I say, well, here's my line, and my angle of elevation, I'm going to call it, let's say it's B degrees. So some angle B degrees. Notice that if I look at my angle of depression right here, it would also be B degrees. In other words, if this is 20 degrees, this is 20 degrees. And in fact, the reason that is because these are, of course, parallel lines because they're horizontal. And so these have to be the same because they're alternate interior. So you'll always get it that the angle of depression is exactly the same as the angle of inclination. And it always works out like this for these pictures. What you're going to do with these angles, okay, and what you're going to do with these shapes is you're going to start solving things with trigonometry. So what you're going to get are things like, we know a building, we know that the angle here is going to be maybe 30 degrees, and we're looking for, let's say this, the height of the building, and maybe we know the distance from where I am to here. Okay, maybe I know these two distances, in which case, I don't know, make this 50 degrees, or 50 meters, pardon me. Okay, so this is 30 degrees, and that's 50 meters. What we can get here is to solve for h, I'm going to use tangent. And I'll tell you right now, with all of these problems involving elevation, okay, you will always use tangent. And the reason is because we won't know this. We'll never know this, but we will know heights and we'll know distances that are horizontal. And so you're not going to be using anything else but tangent. And I can see here the tangent of 30 will equal h over 50, in which case h will equal 50 times tan of 30. And I can type this in my calculator and get an answer. But that's how you're going to start solving some of these things. The same way you do with the other one if it's an angle of depression. Very similar way. But you'll start seeing these patterns come up, and it's not too bad. You're using basic trig, sine, cos, and tan, and as I told you, we're just going to focus on tangent for these problems.